In this example, we're going to solve the system of equations by graphing. So to do that, since both are linear, we're going to use slope and y-intercept. So first of all, for the first one, b, the y-intercept is what's being added or subtracted, so -5. And my slope is what's connected to x by multiplication, so 2. We'll plot our y-intercept of -5. As a fraction, slope is 2 over 1, so we're going to go up 2 over 1, up 2 over 1, up 2 over 1. It is important when you're solving using the graphing method, you have a good graph. So I'm hoping to draw this nice and straight. There we go. Okay, for the other one, doing the same thing. My y-intercept is supposed to be added and subtracted, so it's the +1. And my slope is what's connected by multiplication, so it's that 1/2. So we'll plot our y-intercept of 1. And then I'll use my slope, which is up 1 over 2, up 1 over 2. Looks like I can clearly tell where they're going to intersect. So there we go. Now remember, the solution is where they intersect. We do have to keep things straight though. This is a system. The solution for a system is both the x and the y value. So it's the order pair 4, 3. If it's not a system, then you just use the x value. But since it is a system, we use both x and y. Okay, so in this video, we're going to solve the system of equations below. I'm going to do this one by substitution first. So starting off with substitution, I need to make sure we have one of the equations with one of the variables by itself. That's not the case right now. As far as which variable would be easiest to get by itself, either this x here, because the coefficient is 1, technically -1, or this x here would be easy to get by itself too, because all the other numbers are divisible by its coefficient. So that makes it pretty easy to get by itself as well. I'm going to choose to work with the first one. So to get x by itself, I will add 12y to both sides. Get -x equals -6 plus 12y. X is not quite by itself. We still have to get rid of the negative, which is technically a -1. So we'll divide everything here by -1, giving us x equals +6 minus 12y. As a side note, I could have also done it like this, and some people prefer doing it this way. I could have added x to both sides. Got -12y equals -6 plus x, and then added 6 to both sides. You got -12y plus 6 equals x. They're both the same thing. Some people just prefer doing it this way over here. But either way, we have x equals 6 minus 12y, maybe just in a different order. Now that we have that, that was our first step for substitution. We'll go to our other equation and replace x with the 6 minus 12y. So we're going to have 3 times 6 minus 12y plus 6y equals 18. Now we just have to solve this, so I'll distribute it through. 18 minus 36y plus 6y equals 18. If I combine like terms, actually, this was second step, and now we're working on third step. Combine like terms here would give me negative 30y. It's 18, and we still have our 18 coming down. Now it's just a two-step equation, so we'll subtract 18. We get negative 30y equals 0. A lot of people freak out if there's a 0, but don't freak out. It's okay. It happens from time to time. We'll divide both sides by negative 30. Get y equals 0. 0 is a perfectly good number. It happens. It comes out as part of the solution. So don't freak out if that happens. So we've got one value. We still need to go back and find the x value. So I'll go back here to find this equation. My steps. And I'll replace y with 0. So we're going to have x equals 6 minus 12 times y, which is 0. Just have to simplify this, and then I'll have my x value as well. 12 times 0 is 0, so we have 6 minus 0, which is 6. So the solution is x is 6 and y is 0, or the order pair 6, 0. In this video, we're going to solve the system of equations below using the elimination method. For the elimination method, the first thing we need to check to make sure is that both of our equations is in standard form. And they are. We have x and y on the same side, and our coefficient, or our constant, on the other side. So we're good on that end. The second step of elimination is to make sure one of the variables have the same coefficient. Unfortunately, neither one does, which means we're going to have to multiply one or both equations by something to make the coefficient the same, but with just a different sign. So sometimes it's your choice as to which one to do. Sometimes one choice is easier to make than the others. Just depends on the situation. In this case, we can either eliminate y by multiplying the second equation by 2, or we can eliminate x by multiplying the first equation by 3. I think I'm going to multiply the first equation by 3 to get rid of the x. That's going to turn the first equation into negative 3x minus 36y equals negative 18. My second equation, I don't have to adapt. So 3x plus 6y equals 18. Now we can see that we have the same coefficient with different signs beside the x's. And that's our goal here for that second step of elimination. Once we have that, the third step is to add the two equations. So negative 3 plus positive 3 will cancel out. Negative 36y plus 6y is negative 30y. And then negative 18 plus positive 18 is 0. To finish solving, the next step here is to divide both sides by negative 30 so that we can get this y by itself. So y would equal 0. That's that fourth step. However, remember, a system has solutions x and y, so we still need to go back and find what the x value is. So I'm going to go back to one of the original equations. I'm just going to choose the second one this time. No particular reason why. I'm going back to the original equation. I'm going to replace y with 0. So we're going to have 3x plus 6 times 0 equals 18. Now we just have to simplify and solve this equation, and we'll have our x value. 6 times 0 is 0. We never have to add 0 to anything because 0 is the identity, and adding 0 doesn't change anything. So we're just going to bring down the 3x equals 18. And I'll finish solving by dividing by 3. Get x equals 6. So the solution is x equals 6, y equals 0, or the order pair 6, 0. So in this example, we have a world-famous Mikey's Pizza sells pizza by the slice. Plain cheese costs $2 per slice, and a slice of pepperoni costs $3 each. If you buy 12 slices of pizza, and your bill is $32, how many slices of cheese and how many slices of pepperoni did you order? So since we're looking for the number of cheese and number of pepperoni slices, we're just going to call x the number of cheese slices. And y the number of pepperoni slices. Okay. Usually in systems word problems, you'll look for totals. So we have two different totals here. A lot of the times totals go by themselves. Not always, but most of the time they do go by themselves. So we have $12 is our total, our first total, and our second total is the 32. And I think I said $12. I just mean 12 because it's 12 slices of pizza. Well, with how we have it set up, x is the number of cheese slices and y is the number of pepperoni slices. So if we add the number of each together, we'll have the total number of slices ordered, which was 12. For the money, well, we spend $2 per slice of cheese. So if we're buying X cheese, then we're spending 2 times X on cheese. And if we're buying Y pepperoni pizzas or pieces at $3 each, it's 3Y. So here is our system of equations. To solve this system, you can either use elimination or substitution. I'm just going to use substitution. So I'm going to subtract, or I'm going to start with this equation, and I'll solve it for one of the variables. So I'm just going to get y by itself, so I'll subtract x. So y equals 12 minus x. I'll go to my other equation and replace y with 12 minus x. So we'll have 2x plus 3, replacing the y with 12 minus x equals 32. We'll solve this equation. So we're going to distribute. So 2x plus 36 minus 3x equals 32. Combining like terms, I get negative x plus 36 equals 32. Now it's a two-step equation. So we have negative x equals negative 4. Now, one thing I often see is people losing that negative sign with the x going down, but it is important because then we would say we bought -4 slices of cheese pizza, which means, yeah, you can't buy negative slices of pizza. So if you ever end up with a negative on word problems, something probably went wrong, whether the word problem was created wrong, or you made an algebraic mistake, or if you're applying this to real life, the situation just doesn't work out and something actually is wrong with the scenario. So one of those things is probably true if you end up with a negative for a solution for a word problem for systems. It's not very common that you should have a negative. But then I'll finish it off by dividing by -1 on both sides. We see that x is actually +4. So we're ordering 4 slices of cheese. If I go back up to my box equation here and replace x with 4, we'll find out y is 8. So in summary, we have ordered 4 slices of cheese and 8 slices pepperoni.